What is petroleum? So we have this extraction of petroleum. I don't know if it's still in geography, but you find petroleum in under the layers of earth. So like these different layers, then you have water here, and then you have petroleum under. Then on top of petroleum, you will have natural gas, and then certain rock, and then some other rocks, and then you have the seabed, and then you have the sea. So what people do is they will set this up on top of the section of the earth's surface that contains petroleum, sorry. Then they will extract petroleum in this manner. So petroleum is a viscous, foul-smelling, dark brown liquid. It is a mixture of hydrocarbons. So it means that petroleum is made up of carbon and hydrogen only. So then they say it's a mixture of hydrocarbon. That means there is more than one type of hydrocarbon inside this petroleum. So the hydrocarbons will have different boiling points. So they can be separated by fractional distillation. Okay, do you still remember what fractional distillation is? What is it used for?
Just for separating mixture that have different boiling points.
So usually to separate liquids or gases, right?
Yes.
Okay. So you have a fractional distillation setup for crude oil or petroleum. So what you do is you pump in crude oil into this thing called the furnace. So you heat up the crude oil. Then after that, it will be passed into the fractionating column, just this. So the fractionating column will be able to separate the different components into different sections with the lightest one, right? The short chain hydrocarbon, the lightest on top, and then the long chain heavy ones below. So you see there is 1, 2, 3, 4, 5, 6, 7. Yeah, 7 fractions. So you will need to know the order, which fraction comes out first, and then which fraction comes out last. So you need this order. This you need to know. So then after the fractionating process, right, you can just collect respectively at different locations of the fractionating column. So these different fractions will have their uses. You see, so there are many uses that you need to take note of. Okay, they already tell you down here that the one on top is the smallest, the one below is the heaviest. So the lightest one has the least number of carbons, and the long chain ones have the most number of carbon. And within one group, right, you see that there is 5 carbon to 10 carbon, means petrol itself is also a mixture. So naphtha is also a mixture, kerosene is still a mixture. It's just that the boiling points are close enough and then they come out together. Okay, so then we have questions like this. So why, okay, if the fractions become bigger, that means the number of carbon become greater. Why is there a boiling point? So this is one of a question. So you could imagine that your organic compound, your hydrocarbon is something like this. The big one is carbon, and then the small one is hydrogen. It could be like this. So this is like a 5 carbon chain. Then if you have others, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10. Looks like a caterpillar. So like this. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon. Okay. Then this is a 5 carbon. So the 10 carbon has a higher boiling point. This one has a lower boiling point. Then they'll ask you why. Then down here is written, the intermolecular forces between molecules increases when the size of molecule increase. Therefore, more energy is required to overcome the forces, and there's an increase in boiling point. Do you understand what this tree line is talking about? Do you know what that one is saying? So what is it saying? What does it mean?
The bigger the hydrocarbon molecule is, the stronger the intermolecular forces is.
Okay, so for example,
and more energy is needed to overcome the forces of attraction.
Why is there more for intermolecular forces of attraction?
Because the size of the molecule increases.
Okay, so it's like this in the image I draw down here. The straight line is the molecule. Then we have a few of them together. So you look at it, right? If it's long, there is higher surface area. When there's higher surface area, there is higher chance to form more intermolecular forces of attraction. So if I have another one, which is a huge molecule, so it's like this, you see. So because it's big, you get a lot of opportunity to form a lot more intermolecular forces of attraction. That's what it means. Then they say, why do fractions become less flammable? That means it doesn't catch fire as easily. When the fractions become bigger, it becomes less flammable. So the explanation is because the percentage by mass of carbon in the molecule increase. That means there's more carbon and lesser hydrogen percent. So it will become less flammable. Then why do fractions become more viscous? Viscous meaning that the liquid doesn't flow well. So the intermolecular forces between molecule increase, then the forces are difficult to overcome because we need energy, and then the molecules will tangle. So the larger hydrocarbon become thick and waxy because of the intermolecular forces. Then there's this thing called volatile. Fractions become less volatile when the molecule become bigger. Less volatile, that means it doesn't evaporate easily. So it's again because of the intermolecular forces of attraction. So you need more heat. More heat is required to break the forces to change their physical state, so it becomes less volatile.